You know the networks are there, but how does the data itself move through them? What's going on when you send a message, stream a video, or play a game online? That's where data communication takes over. In this next part, we're diving into the flow of data, unpacking the processes that allow your digital world to function smoothly. Ready to jump in? Let's continue.
Hey everyone, ever hit send on an email and wonder how does this actually get there?
Or, dealing with buffering videos and thinking, what's the holdup?
Exactly, it's like magic.
Yeah.
So in this deep dive, we're breaking down data communication.
Those invisible forces that literally power our digital lives.
We've got excerpts from computer networking textbooks.
Some deep dives into essential internet protocols.
Even insights into wireless communication.
Mm-hmm.
A whole treasure trove of sources to guide us.
And you know what's fascinating? All these sources really emphasize this concept of layering.
Layering.
Yeah, the foundation of network architecture. It's like, imagine a network as a well-organized office building.
Okay, I'm picturing it.
Each floor has its specialized department all working together.
To keep things running smoothly.
Yeah, and each layer in a network handles a specific part of the communication process.
Makes sense.
With clear interfaces between them. This is key for flexibility and innovation. Think of it like being able to renovate one floor without disrupting the whole building. Oh, so we could swap out old copper wires for super fast fiber optics.
Exactly. On the physical layer.
Right.
Without affecting how emails are sent and received on the application layer above.
That's brilliant.
This layered approach allows for constant evolution and upgrades.
Without bringing the whole system down.
Yeah. It also means that your phone and your laptop, even though they have different hardware, can still communicate.
Seamlessly.
Seamlessly. Exactly.
It's like they have a universal language.
Right.
But okay, how does the data actually get from point A to point B?
Well, the sources really get into the nitty-gritty of the physical layer.
The physical layer.
Talking about copper wires, fiber optic cables, even radio waves.
Right.
Data needs a physical medium to travel on.
Okay.
And each medium has its own strengths and weaknesses.
Right.
Like copper wires, they're reliable but limited in speed and distance.
Think of them like?
The old school telephone lines.
Okay.
Fiber optic cables, on the other hand, use pulses of light.
Oh, to transmit data at super high speeds over long distances?
So fiber optics is like the supersonic jet of data transmission.
It is. But one source mentioned that even our trusty TV cables
Really?
can be used for internet access, turning them into information superhighways.
That's so cool.
It is.
Repurposing.
It's a great example of how we can repurpose existing infrastructure
Right.
to meet our ever-growing data demands.
Makes sense.
But regardless of the medium, we need clever ways to transmit the digital data as signals.
Right. That's where we get into modulation and multiplexing.
Exactly. Modulation techniques convert digital data into analog signals
Okay.
that can travel over physical mediums.
Like translating our thoughts into spoken words.
Yeah. Different modulation techniques create unique signal patterns to represent the data.
Okay, I get that.
And then multiplexing, it's like having multiple conversations happening at the same time.
On the same phone line.
Yeah. Multiplexing allows multiple users to share the same channel.
Okay.
Think of it like lanes on a highway,
Yep.
each carrying data from different sources.
Well, gotcha.
These techniques are essential for maximizing the efficiency of our communication channels.
Right.
But networks aren't perfect,
Right.
and errors can happen along the way.
Oh, yeah, for sure. So how do we make sure our messages arrive intact?
Well, that's where error control mechanisms come in.
Okay.
They add a little bit of redundancy to the data.
Like sending a backup copy just in case?
Exactly. Like techniques like Hamming codes and convolutional codes.
Yeah.
They provide different levels of protection against errors.
So it's like having a safety net
It is.
for our data.
Ensuring that the information arrives safely at its destination.
That's reassuring.
But what if the sender is blasting out data like a fire hose
Right.
and their receiver is struggling to keep up?
Yeah, wouldn't that create a digital traffic jam?
Absolutely. That's where flow control comes in.
Okay.
It prevents the sender from overwhelming the receiver with too much data at once.
So it's like a traffic light system
Yeah.
for data.
A great analogy. One common method is the sliding window technique,
Sliding window. Okay.
which regulates the amount of data that can be sent at any given time.
Gotcha.
It's like having a controlled queue for data packets.
To make sure nothing gets lost.
Yeah, or delayed.
Okay, so we've got our data neatly packaged, error-proofed, flowing smoothly.
Great.
But what about when we want to cut the cords and go wireless?
Ah, the realm of wireless communication.
Right.
Wi-Fi has become ubiquitous.
Extending our networks beyond the reach of cables?
Exactly. But as you can imagine, transmitting data through the air
Yeah, I can only imagine.
comes with its own set of challenges.
Like radio interference,
Yeah.
signal strength, those kinds of things.
You're on the right track. We also have to contend with something called the hidden terminal problem.
The hidden terminal problem, okay.
Imagine two devices trying to communicate with a third device,
Okay.
but they can't see each other.
Because they're out of range.
Yes.
Oh, so they both think the channel is clear and they end up talking over each other.
Exactly, creating a jumbled mess.
A real mess.
That's why robust protocols are crucial for managing the complexities of wireless communication.
Right.
Yeah.
This is fascinating. It sounds like there's a lot of behind-the-scenes wizardry happening every time we connect to the internet.
There certainly is.
Right.
And speaking of robust and efficient, our sources also delve into gigabit Ethernet.
Gigabit Ethernet, okay.
The evolution of wired networking to handle our insatiable need for speed.
So that's what enables us to download movies in seconds
Exactly.
and stream high-definition videos without a hitch.
Precisely. 1000 base T is a prime example.
1,000 base T.
It's a clever technology that allows us to achieve gigabit speeds over existing Category 5 UTP cables.
So no need to rip out all the old wiring.
Right.
Phew, that's a relief. But as networks grow larger and more complex, how do we ensure that data gets to the right place?
That's where routing comes in.
Routing.
Routers act like traffic directors,
Okay.
guiding data packets through the network maze to their final destinations.
So they're like the GPS systems of the internet.
Exactly. One of the classic algorithms used for routing is Dijkstra's algorithm,
Dijkstra's algorithm, okay.
which calculates the shortest path between 2 points in a network.
I see.
But even with efficient routing, we can still encounter issues when too much data floods the network.
Oh, you're talking about congestion, like rush hour traffic.
Precisely. Congestion control mechanisms play a crucial role in preventing network meltdowns when traffic gets heavy.
Okay.
Imagine a highway with no speed limits and traffic signals.
Oh my gosh.
It would be chaos.
That's a scary thought.
Yeah.
So congestion control is like having a traffic management system for the internet.
Exactly. One analogy used to describe congestion control is the token bucket.
Token bucket, okay.
Imagine a bucket with a small hole at the bottom,
Okay.
representing the network's capacity.
Okay.
Data packets are like drops of water flowing into the bucket.
I'm picturing it.
And the hole regulates how quickly they can drain out. If the bucket overflows, we have congestion.
That's a great way to visualize it. So it's all about maintaining a balance
Yes.
between the flow of data and the capacity of the network.
You've got it. It's a delicate dance, and there are a lot of clever mechanisms in place to keep things running smoothly.
This is mind-blowing stuff. From physical cables to traffic management systems for data.
I know. It's amazing to see how much complexity is involved in something we often take for granted.
Absolutely.
Yeah.
Wow, this is incredible.
It is, and we've only just scratched the surface.
Stay tuned for part 2, where we'll delve into the specific protocols that govern how different applications communicate over the internet.
Exactly.